This conference will now be recorded.
Okay, so today we'll discuss with some other concept, dimensional modeling. Last class we discussed data warehouse, some introduction, fundamental concepts. Today we'll discuss dimensional modeling, and after complete we'll go for the business intelligence, few concepts with ETL process. Okay, so for today's topic in dimensional modeling, fact, dimension, hierarchies, and level. Next is fact and dimension table. Then what is measures? How many types of measures are there? What are those examples? OLEP, what is this? Then schema. Then what are the different types of schema? Metadata, what is that? Dimension types, slowly changing dimension. So all are important today. And from today class, only you will get at least 5-7 questions in the interview also. Okay, so first of all, you can try to understand the normal meaning or generic meaning of the concepts terminologies, and then you can correlate with the technical data warehouse, ETL, business intelligence, all those concepts. Okay, so first one is fact, dimension, hierarchies, and level. Okay, what is fact? Fact is the key performance indicator, handles the numerical value to analyze the business. So as per our technical terminology which we are learning, we have to tell this line of definition. But to understand what is fact, just we can take one simple example. Suppose one event is going to organize any event, marriage function or any party, or you are going to travel one place for 1 week or 2 days or 3 days, that is called as an event. You are going to attend one marriage function, marriage ceremony, that is one event. You are going for one party, night 6 p.m. or 7 p.m., that is one event. Then you are traveling somewhere, one tourist spot or somewhere you are traveling, that is also one event. So any kind of, you are going for shopping, that is one event. So any kind of activity you are going to perform, then that is called as event, which is your plan. So in simple word, it is called as event only, and that is your objective, that is your goal. Today you are planning for that, tomorrow you will plan for that. So that is called as event. So that event is nothing but the fact. Any kind of event is happening, then we can tell it as a fact. Now, to attend that event or to execute that event, what are the different parameters are required? Those are called as dimension. Suppose you are going to attend one marriage function. So in that marriage functions, to whom you will go, by which vehicle you can go, then in which time you will go, any gift you are taking or not, dinner lunch plan is there or without that you will come back, then you will stay there or not stay, so how many hours plan it is there. These are few parameters. Without this detail level of your planning, you cannot go to event. Simply you can go and you can come. What is the use of that? So if you are doing something, then some plan is there in detail level, in high level. High level you are going to attend. That's all. In detail level, with whom you will go, how you will go, what is the expense, in which vehicle you will go, when you will come back. These are detail level plan. So this detail level plan is called as dimension, and high level plan is called as fact. So same thing here, coming to the project level also, or technical level, if you are coming into data warehouse, ETL, all those terminology, any informations we are getting, which is the key performance indicator, KPI, that is the indicator, main in objective or high level approach. So that is called as event, and that event also, again we can tell it as a fact, event or fact. So for our understanding, event we can tell, but for this terminology wise, fact we can tell. Okay, so to execute or to activate or to work for that event or fact, we need some more details. Those are called as dimensions. So suppose in this technical level, we can take one example. You are working in one healthcare project. So in that healthcare project, uh, your main requirement is find out the list of new disease which happened in last 1 year, COVID time 2021, how it is rectified, then how many people cured, how many people not cured, and what is the what we can tell. expense is there. So this is the main intention objective. So we have to develop that requirement, we have to test that requirement, and we have to give that requirement to the client. Client is expecting those few information. Now to activate all those or to work on those, we need so many details. What are the patient, from where they are coming, how the disease start, which doctor prescribe, before that where they check. A lot of informations are required. Based on that only doctors can means go for the surgery or whatever they want. So in this technical level, if you are working the project, for all those details of data, how we will receive? We will receive with some tables. So patient information we will receive in one patient table, disease information in one disease table, then doctor information in the doctor table, and how the surgery are happening, all the details process will be mentioned in another table. Then hospital address informations will be another table, hospital table. Like that 10 to 15 tables we will get. So each and every table containing the detailed information specific to that area. Patient area, all patient details. Hospital table, hospital details only you will get. So those are called as dimension table. In detail level, those are present. Now, by extracting the data information from all those tables which are required for our requirement, that only it will take and keep into final table. That is the data warehouse related table or fact table we can take, we can tell. So that is the fact table or fact information is present. So main objective, main motto in high level which will be present, that is called as fact, and in which table that is present, that is called as a fact table. Detail level information is called a dimension, and if it is present in some table, then that is called as a dimension table. Okay, so simple, only high level, detail level, that's all here. Okay, now coming to dimension, in real time scenario, you will get this type of categories: geography dimension, time dimension, product dimension, customer dimension. These are different category you will get. So location specific wise, zone wise, north, east, west, south, country, state, district. If location wise it is coming city, then those are called as, those type of tables are called as geographical dimension table, or those informations we can tell it as geographic dimension. Time related, if you are getting quarterly, then yearly, half yearly, daily, weekly, weekend, night, day, all this time factor is coming yearly, then a decade, century. If this time factor is coming, then those type of informations are called as time dimension. And if that is mentioned in one table, then that is called as a time dimension table. Similarly, product. Products also, a lot of categories are there: electronics product, then food related product, medicine product. Many products are available. So product related informations we are getting, and those are product dimension. Customer related information: Visa customer, credit, then Amex customer, then any other Mastercard customer. These are related to customer type of the card. Those are customer dimension. So in this way, these are few examples. The dimension is divided, or dimension is categorized in this multiple way. Next is hierarchy. So whenever we are going any project, the hierarchy will be there in that project also. So to understand this hierarchy, also we can take one simple example. Suppose one organization example we can take: TCS, IBM, Wipro, Infosys, anywhere you are working or somebody is working. So how the hierarchy structure is there? First of all, in a project, some team members will be there. Those team members will report to team lead. Team lead will report to manager. Manager will report to senior manager. He will report to delivery manager. Like that, some other teams also there, same structure they are doing. Now those delivery manager will report to some other higher management, director. Director is report to CEO. CEO is reporting to MD. Like that, all hierarchy structure is going on. So in top level, who is there? Top level owner or CEO or managing director, they are available. So whole together, what is this? This is a structure of that company. In that structure of that company, different levels are there. So you are in junior level, team member. Next level will be team lead. Next level will be manager. Next level will be delivery manager. Next level will be director, suppose. Like that, these are different points, different levels. So hierarchies is nothing but the structure, and in that structure or hierarchy, different levels are there. Okay, so using that level, But by taking that level only, we can understand that these are different steps. Next step, next step, next step. Like that, you can understand. Suppose you are coming for testing. Direct you are going to big data testing, it will not work out. You have to learn manual testing, first level. Then second level, you have to learn for the database related testing, second level. Third level, you can learn ETL data warehouse, those concepts with some tool, third level. Then you can learn Unix and Street, fourth level. Then you can go for big data testing, it will work. So anywhere you can go, one structure is there, and within that structure, some levels are there. So in your project also, if you will work any data warehouse, ETL testing or ETL related project, that project will be having one hierarchy, one structure. And that hierarchy structures are having multiple modules, 10 modules, 20 modules, or 30 modules, or different features you can say, or different components you can say. So first of all, that project will be divided into suppose mainly three modules. Those three modules again subdivided into three modules, total 9. Those 9 modules again divided into two modules, 18. Like that it will happen. So all together that structure is called hierarchy, and all those individual point by point or step by step which are going on, those are called as levels. Okay, so these are four very basic things to enter this dimensional modeling concept. Okay, so this level represents a position in a hierarchy, and hierarchy is nothing but the structure whole total. Okay, next is fact and dimension table. Now using this information, fact and dimension, some tables are there: fact table, dimension table. So what is fact table and what is dimension table? This is compulsory question. What is fact and dimension table? Anywhere, any interview you can go, fresher, experience, 10 year, 15 year, 20 year, for everybody. Okay, so fact table contain fact information, summary information, or high level information, overall approach informations, that is called as fact. Then dimension is detail informations. So detail informations tables if you are getting, then we can tell it as a dimension table. And summary informations if we are keeping, then that is called as a fact table. Suppose your scenario also you can take. Your main intention is to get a job. That is a fact. But for get a job, what are the different criteria, parameters you have to do? You have to learn some course from somewhere, then you have to do practice, then attend interview, then provide the documents if selected, then you will get the offer letter, then you can join, then you can work. So these are different steps. So detail level, if you will manage for practice, you can effort some time, 2 months or 3 months or 4 months. So that is called as a time dimension. Now, what are the products required for your practice? What are the softwares required? Those are product dimension. So if you will categorize all those things, then different dimensions you will get: product dimension, time dimension, then some other dimension. Now, to meet your expectation, that is the fact. At the end, your goal is to get a job and sustain your family, or you have to take a loan, or whatever you want, you can do. So here also in our project level, we will get some requirement. What is the main objective of that requirement? What is the main intention of that project? Based on that, we have to work. We have that goal. We have to meet that goal. So that information in high level, it will be loaded. It will be kept in some table that is called as a fact table. And to generate those type of informations or data, we have a lot of tables. Some small tables will be there in detail level. So we can tell those as a dimension table. So coming to database, dimension or we are not using in SQL, Oracle, or any other database. So what is that? That is also dimension table. Employees, then HR related information. So one company related information is there. HR is a schema. So all those are one table: employees, then locations, then another is called as departments, then regions, countries. All those are one table. So what type of table? Those are dimension table. Since in the database level only one type of table is present, so we are not telling it as fact table or dimension table or any other table. But coming to this data warehouse ETL concepts, multiple table types are there. Data, what we can tell, one is fact table, and another is dimension table, and another is another kind of table also there that is not used frequently. Fact and dimension only using. So three categories of table are there. only table if you will tell, then what type of table? It is fact table or dimension table or some other table. That's why it will confuse. So in ETL data warehouse project, if you are working, table what you are telling means we have to specify what type of table, fact table or dimension table or some other table. Otherwise it will be confused. But in database level, only one type of table is there. So no need to tell fact, dimension, all those things. So if we correlate, if dimension table we are getting here in data warehouse level, but in database only table we are telling. So this is what type of table actually, fact or dimension. So that is fact table, sorry, the dimension table. Detail level only it is present. Employee information one table, department information another table. So those are detail level of table and dimension table. Okay, so this fact table contains business facts or measures and foreign keys, which is referred to the candidate key, normally primary key. Okay, so primary key, foreign key we have not covered in SQL. For few one that it is covered. Okay, so primary key means what? It will be unique value. It will contain in that column. Suppose employee ID, it will not take any null and it will not take any duplicate. Then we can tell it as a primary key. And another kind of key is foreign key. So what is foreign key? Foreign key will contain duplicate value. It can contain null also. So two type of keys are there, foreign and what is called as primary. So these two will be parent-child relationship whenever we will combine the table. So this primary key will be present in dimension table and foreign key will be present in fact table. So which is the primary key in the dimension table? Suppose employee ID, the same key means column. So the same column will be present in the fact table also. So that both will be the common column. Based on that common column, the data can be combined. Okay, so fact table hold the data to analyze. Using this fact table, data can be analyzed because summary information is present here. Crores of data and huge collections of data will be not present here, which are required. That only limited data it will be present, and that is the main intention or objective or motto of the project, so that it will be used for analysis purpose or analyze purpose. Okay, so here some example given. A store selling automotive parts might have a fact table for recording a sale of each item. This can be one example we can tell. The fact table of an educational entity who track credit hours awarded to the students. So any students are available in a college. In college, one summary table they will mention in high level what kind of students are coming from which zone, what are their status, then percentage, how many people are getting more than 80%. So this summary they are keeping into one table that will be called as a fact table. And for each and every student, if detailed information they are keeping, then that will not go to the fact table. That will be another table. That will be the dimension table. So any kind of example you can take in healthcare sector, telecom sector, banking, insurance, anywhere, data warehouse is required. Every project they are using data warehouse to store the historical data. And if data warehouse is there, then fact dimension, both concept compulsory they are using. Okay, now here this is two example of one fact table and another is dimension table. Okay, so what is fact table? Here you can see the data how it looks like in the fact table. So this first one's left side is fact table and second one is the dimension table. So first of all we can see dimension table. Here customer ID, customer name, gender, all these are available. So what type of dimension it is? Customer dimension. So in this customer dimension table, all the detail level of customer are present. Customer ID, customer name, male, female, gender, what are their income, then education of those customer. Some ID is their education ID, maybe 3 means MCA, 5 means BTech, like that suppose. Then region, some region code is there based on the city or area. So these are few detailed informations present in this customer dimension table related to customer details. Similarly, other table will be there. I have not mentioned here. Another we can take it as a product dimension. So another table will be there. That is another dimension table, product dimension table. Similarly, another dimension table will be there, time dimension. Okay, so here only one customer dimension example is given. So these are different dimension table. So in all these dimension table, some primary key will be there. One primary key will be there. So customer ID is the primary key in this customer dimension table. And coming to this product dimension table, product ID will be the primary key, suppose. And for time dimension table, time ID is the primary key. It will not contain any duplicate value. It will not contain any null value. So this is the unique ID to identify. Like if you are working in a company, you are having one employee ID. So your employee ID, if you will check, then you are the unique person. But name, if you are checking, then maybe same kind of names are present 20 persons in the company. Rakesh. Different teams, different projects they are working. Rakesh name. So to identify which Rakesh, we need the employee ID. Similarly, for all the dimension table to identify the unique row, unique record, unique informations, we need one key, one column. Based on that column only, like employee ID, based on one that column only, we can uniquely identify that this is represent to this row, this information, this is represent to this row, this information. That's why this primary key is required, and for each dimension table, one primary key is there. PID, then time ID, customer ID. So here one primary key and other are some information, different informations in this dimension table. Now come to this fact table. This fact table will contain two parts. One is key section and another is measure section. Okay, so in key sections, it will be present with all the foreign keys that will come from these dimensions table, which are present in dimension table as a primary key. So this customer ID is one primary key in this customer dimension table. So this data is coming to this fact table, customer information with customer ID. Okay, so this common column is there, then only we can take and combine the data. Okay, so customer ID is there. Similarly, product information also we want to take in this fact table. So one common column is required, product ID. Here also product ID is there. So this will come here. So in this dimension table, this is a primary key, but coming to this fact table, this will be the foreign key. Because from multiple tables it will come. So chances is there null can come or a duplicate can happen. That's why we cannot tell this as a primary key. It will be the foreign key. Similarly, time ID, it will come from another dimension table, time. So similarly, if 10 tables or 20 tables are there, from each tables, it will come with all those primary key, but whenever it will come to this fact table, it will be called as foreign key. So all these are key sections: time ID, product ID, customer ID, city ID, state ID, country ID, then employee ID, department ID, location ID. All these ID related columns are called as key column. So one section is key section. So here also you can see one column is time ID, another is product ID, and another is customer ID. So this is one part or one section you can tell. So this is called as a key section. So all these ID related columns or key related columns are called as key section. And another is measure section. Except this key, any other columns are there which will represent with some numeric value or gender or income, education, product name, then address of the customer. Those informations are called as measure section, which can be changeable. It is not fixed. Key section is fixed. Suppose you are working in one project, so that project ID is 2345. So you are fixed to that project. You are working for 2 years, 3 years, or 5 years, or 10 years. You can work in that project. You have one bank account. So in that bank account, for your login, customer ID you have to use. So till you exist in that bank, online you are doing, then that customer ID is fixed. It will not change. Okay, so if you are opening any other account, then you will get another account number for that bank. Suppose ICICI Bank. So ICICI Bank, you can get account number. Account number can be changed. Suppose you are available today in Hyderabad. After few months, you will go to some other location, USA or UK. You will have another ICICI Bank account. There also you can open. So you have another ICICI Bank account, but your customer ID will be only one, 1234, then 1234 only. It will be linked to that customer ID with multiple account. So here, which is measure section account number, we can tell it as a measure section because that is changeable. It can be changed. If you will close that account, again you can open another current account. Yes, fine, but your customer ID is same 1234. You can close that account, again you can open some other type of account. Another account number you will get. Those are changing, but customer ID is not changing. So few key columns are there which are not changing frequently. It will take more time and a lot of rules regulations are there if you are going to change. Those are called as key sections. So these are static, not changeable. But coming to measure section, these are dynamic. It can be changed. Address can be changed. Today you are selling 2 quantity, tomorrow maybe it can sold out 5 quantity. Those are changeable. Today you are staying in Hyderabad, tomorrow or after 1 month you can stay in Bangalore. That is changeable. So which are changeable and some numerical informations we are getting, and that is not a key type of collections, not ID related, then those informations we can tell it as a measure. So two types of sections or two types of data will be present in this fact table. One is key related and another is measure related. So here in measure related you need sold one column I have given. It is not like that only one column. It can be any number of columns, 2 columns, 4 columns, 10 columns, any number of columns. So those column also it will come from those dimension table. Few columns will come from this dimension, few columns will come from this dimension table, few columns will come from this dimension table. And while it is coming, some expression also it can be added, some functions or some expression, some calculation, or salary is there, suppose here, or income is there. This is monthly income. So while it is coming to fact table, maybe our requirement is annual income. So it will multiply with 12 and that value it will come to this fact table. So it can be some expression that is called as one expression. So it can come directly straightforward one to one column also, using some calculation with expression also it can come, combinedly few columns also it can come. Suppose your first name is there, another column is last name is there, but coming to this fact table it will come as full name. They don't need separately first name and last name with one space. So using concatenation operator it will come to this fact table. Okay, so in this way, different informations will come from all those dimension tables. So at the end, what we are getting, two types of sections we will get. One is measure sections, which can be changeable and not any key value, and one is key sections, which are fixed, not changeable, and coming from the dimension table, and here it will behave as a foreign key. Okay, so this is about fact table and dimension table. So what is the difference between fact and dimension table? They are asking. In the interview also compulsory you will get. Okay, now next kind of table is factless fact table. So this use is very less factless fact table, but as a concept we should know. So what is this factless fact table? Here only key section will be there. Student ID, class ID, time ID, product ID, region ID, city ID, state ID, country ID. Only key section will be there. No measure section. So without measure, only key value are present in any table, then we can tell it as a factless fact table. Okay, so if we'll work in any project, you will get 99% fact and dimension table only. Factless fact table will be very, very rare cases it will be there. Like weekend table is there, suppose. So in that weekend, week ID will be mentioned or week number it will mention, and what is the day, that only. So that is a factless fact table. Other informations are not present. Only two types of ID or key sections are present. So similarly, very less cases, rare cases, we will get this factless, factable. But as a concept, you should know, somebody is asking, you should tell this. If any table which is containing only the fact information or key information only, key section only present, measure section is not present, then that is called as a factless, factable. Okay, now coming to measure. What is measure? How many types of measure? So till now we completed the dimension, fact, and related to those tables. Any doubt in those?
No, sir.
Okay.
Yeah, no, clear.
Okay. Next we can go for this measure. So measure part we already covered now. In that measure part, uh, it is basically three types or three categories of measures are there. Okay, so measure is three types. One is additive measure, second is semi-additive measure, and third one is non-additive measure. So based on the addition only, it is derived or defined. Okay, so measures means now you understand what type of examples will come, any address, name of the customer, dollars of sales, number of credit hours. If you have any shop, then what is the percentage of profit you are getting daily basis, then any expenses you are doing daily basis, your expenses, you are getting the salary on first day of the month, suppose 1 lakh, and day by day your expense is going on. So those every day your expense is not same, one day 5,000, then another day 20,000, like that. So all these are coming under example of measures. So those type of columns are present in a table, measure columns. Then we should understand which measure column is a additive measure, which measure column is semi-additive measure, and which measure column is non-additive measure. Okay, so based on the addition only, the name is given. Here additive, semi-additive, non-additive. Three types of only additive, additive, additive is there. Semi means 50-50, partial. Only additive means full additive, 100% it should be added. Non-additive means it will be not added, not at all, it will allow to add. Okay, so here additive if you are taking, then what will happen? We are able to add. Suppose one column is there. In that column, what we can take example. Okay, you are selling the quantity. You have one shop, mobile shop. Daily basis, you are selling the quantity. How many mobiles you are selling? So today, 5 mobile you sold out. Tomorrow maybe 3 mobile. Day after tomorrow, 2 mobile, like that. For 1 month, you are selling each day. So at the completion of that month, after completion of that month, if we calculate, or somebody is asking you how many mobiles you sold in this month, March month or February month. So day by day, whatever quantity you sold, you have to add on those. So here what we are doing, we are doing the addition. And after addition, we are getting some result. 1 plus 5 plus 3 plus 2 plus 8 plus 7, like the day by day whatever quantity you sold, you are doing the addition, and after complete that addition you are getting some result, and that result is a meaningful result. You are able to do addition and you are getting the result as a meaningful result, both are there. So in that case you can tell it as a additive measure. So day by day quantity, that quantity of sold item is one column suppose. So we can tell it as a additive measure because you are able to add, and after add also you are getting the result. That result is a meaningful result. In that case that is additive. Now come to semi-additive. So in this semi-additive also add will come, and this finally after adding result will come. Okay, so here semi means partial, 50-50. We will able to add, but after adding what result we will get, that is a meaningless result, that is not meaningful. So this type of column we can tell it as a semi-additive measure. Like example, we can take profit. Okay, so day by day you are counting your profit. Same example only, mobile you are selling in your shop. One mobile shop you have. So daily you are selling 5 quantity, 10 quantity. So each and every quantity, whatever you are selling, some margin you are keeping for your profit. For one mobile, 5% margin. For another mobile, 10% margin. Some another mobile, 20% margin. It can vary. For all mobile, maybe it will be sell, maybe it will not sell. 5, 10, 20, 25, 1, 2% it will come. Now, if you will add all those percentage of profit, or if you are finding out the percentage of profit day by day, then maybe for today you got profit, or March month we can take. March 1 you got profit 20%. March 2 you got profit 30%. March 4 you got profit 40%. March 5 you got profit 5%. Like that, you got every day something profit you got. Now March month completed. If we will calculate now all those things all together, we will do the addition 5% plus 10% plus 20% plus 40% plus 50% plus 15%. Each and every day, if you do the addition, we will get one result. Maybe 700 or something it will come. 5 plus 10 plus 20 plus 30 on this. 700 or 1000% it is coming. So here what happened, we are able to do the addition, but that profit margin which we calculated after addition, we are getting one big figure, 800 or 900 something we are getting. So can we tell 900% profit I got in March month? No, that is meaningless. But we are able to add. So that column we can tell it as a semi-additive measure. We are able to add, but meaning is not there. After addition, that result is meaningless. So that kind of column we can tell it as a semi-additive measure. Now another type of measure is non-additive measure. So here also we have to do the addition only, because additive is mentioned everywhere in these three types. So add is compulsory. No minus, no subtraction, no multiplication, nothing. Only addition we have to do. So here addition we can do and result we can check. So non-additive, not at all possible. So we will not able to add, will not, if we are not able to add, then what result we will get? Result also will not get. Both are not there. So what type of example we can take? Any column example we can take which cannot be added. So address is a major column, it can be changeable, but address can we add? No. In one column address is there. Ramesh is staying in Hyderabad, Rakesh is staying in Bangalore, and Sony is staying in Kolkata. Can you add Kolkata plus Hyderabad plus Bangalore? What is the result? No, we will not get that result. Can we add the date 1st March 2021 plus 2nd March 2021? No, it cannot be added. So few columns will be there which will be not at all add. It will not allow to add. We will stop there only. So we are not able to add, then we will not get the result. So both are not happening here. In those type of columns, we can tell it as a non-additive measure. Okay, so these are different types of measure. Now we can go with some example. This is also one compulsory question. What is measure? How many types? Can you explain this? Okay, so here we can take one example: date, store, product, and sale amount. So here what we can do, okay, suppose here product ID we can take, column name is product ID suppose, and store name suppose this is date wise one column, sales amount, quantity, daily how many quantity it is selling, any laptop shop or mobile shop or anything you can take, sales underscore amount. Okay, amount means price will come, not quantity. So maybe daily basis, then 2000, 5000, 20,000, like that it will come daily basis. Now, can you tell out of all these four columns which are major columns? Which is key column here and which is major column here? If it is a fact.
Key column is product ID.
Product ID.
Yes.
And additive measures as product ID. No, sales amount is additive measure.
Sales.
Okay. So this is the key section product ID. For key sections,
Yeah.
measure will not come. So which are
Right.
measured then? Store name
Date.
is measured,
Yeah. So
date also
date,
measured,
sales
sales
amount.
amount also
Sales.
measured. Now, can you tell out of all these three major columns, which is additive, which is semi-additive, and which is non-additive?
Sales
Okay. So
amount
sales
is
amount is additive.
Okay, additive. Then store name,
Store name is semi-additive. No, non-additive.
non-additive.
Yeah.
Okay. Date,
Date is semi-additive.
semi-additive.
okay, date will be semi-additive. Yes.
Semi-additive.
Okay, date means if the date format is mentioned like this, then semi-additive, like 01/03/2021. If this date is mentioned as 01, then March 21, this is not additive, not
Right.
semi-additive also. You is not able to add. So based on the value, you can see and tell this is additive, semi-additive, or non-additive. So in your interview also, they are asking by giving some scenario example. And can you explain which is additive, which is semi-additive, which is non-additive? So very easy. Just
Yes.
understand that. Okay, so here semi-additive. Semi-additive example, if we'll take here, then current balance. Okay, so profit margin, profit already I told that will be semi-additive. Daily basis profit you are calculating, you can able to add, but you will not able to get that correct result after addition. So current balance, if you are considering daily basis, then it will be additive or semi-additive.
Current balance is
Additive.
Semi-additive.
Additive.
additive.
Yeah.
Okay, so you got your salary, suppose 1 lakh on March 1.
Okay.
Daily basis, your expense is there, 5,000, you swap somewhere, well, petrol or something. Another day, you transfer your home rent, 15,000. Next day, you did some groceries of 10,000. Like that, every day you did your shopping. So at the
Right.
end of completion of month, you are seeing that zero balance you have. You don't have any balance in that bank account. But daily
Right.
basis, if you have a different balance was there. Now we want to see that column, current balance, you are maintaining in a column. So that will calculate after that what you can tell, additive or semi-additive or non-additive.
Additive.
Additive.
How it will be additive?
Because every day we are checking
Sir,
our current balance or day-to-day activities, which is the editable.
we can,
But
so we can
today,
get the result.
Yes.
no, you are getting the result, but total here additive is coming means total result you are taking. So daily you are taking the balance. First day your
Right.
balance was 90,000. Second day balance was 80,000. Third day balance was 75,000. If you are doing addition all those, so at the end of the month it is coming the balance as maybe 4 lakhs or something, but your balance is zero.
Okay.
Semi-addictive, sir.
Semi-editable.
It's semi. Okay, so out of all these three additive measures, additive related measures, in real-time project, if you are working, additive, first one only using, other two are not using, just concepts is there, you can remember. If somebody is asking or any exam, any quiz you are doing, you can tell. Practical use in real time, only additive is there. Okay, next is OLA. Okay, so in that measure, any doubt from anybody?
No, sir.
Okay. Sairam, Lakshmi, Rahul, any doubt? Manasa, Sri.
No,
No,
no
sir.
doubt, no doubt.
Okay. Next is OLAP, Online Analytical Process. So one is OLAP and another is OLTP. OLAP nothing but the data warehouse and OLTP is nothing but the database. Data warehouse is coming from the database only. In database, we can keep up to some gigabyte of data. If terabyte of data is coming, then it will not support. Database will not work. So to increase the means to store all those data with some terabyte level, we have to increase the space or memory in that database. If we are increasing the space or memory up to terabyte, then what is the need? Why we are increasing? What type of data we are using so that we need more spaces? Historical data. If current data, then size will be not more. Less size that is sufficient up to some gigabyte. History is coming, then only 30 years, 40 years history, more memory is there. So historical data plus current data, both informations are keeping in the OLAP server or data warehouse server. So this OLAP full form is Online Analytical Processing Server or Online Analytical Process. It based on multi-dimension. In OLTP, single dimension, that is because separately one table is there. Address one dimension table, patient one dimension table. So those are single dimension. But coming to this OLAP, from multiple dimension table combined together, the data are coming here in this fact table. That is the OLAP table or data warehouse table or fact table, we can tell. So since it is coming from multi-dimensional table, we can tell it as a multi-dimensional data model. This OLAP is a multi-dimensional data model, not single dimensional model. Okay, it use the database tables. So from database only, it will go to this fact table. And here fact, dimension, both kind of combinations of data will come in this OLAP. And we can view the data and it will be used for analysis and query for large amount of data because history is there means large amount of data it will come. So all those together it will be used in this OLAP related data. So who are using this OLAP related data? Some higher management only, business analyst, then delivery manager, then who are involved in some business activity. Those people only they will use that for analysis purpose or their business purpose. So this OLAP server is three types basically. Nowadays, some people are telling four types. That's why I mentioned four. But in many books, if you refer, this last one they have not mentioned. And in starting also, whenever this is defined, the concept somebody defined and we are learning, they have not added this last one. Only these three categories they have defined. One is relational OLAP, another is multi-dimensional OLAP, and another is hybrid OLAP. Okay, now SQL Server is one database. So many new features they are adding from past few years. And in that they have added one OLAP server related some terms also they have added in that database level. And they have given more spaces. That's why in many project SQL Server database they are using for target location, fact table they are using. And Oracle and all those databases they are using for dimension table in database level they are using. So since it is using in fact or data warehouse related information, so few people are telling that this is also one server, OLAP server. So one is relational, one is multidimensional, one is hybrid, and another is specialized SQL server, OLAP server. They are telling, but exactly that is not categories. That is one database, and they have added that feature. So if we are considering what are the different types, these three only we should take. Okay, relational OLAP. So one-to-one relation will be there. One dimension table is there and one fact table is there. One-to-one we are making. From that dimension table only, the data will be loaded into the fact table finally, data warehouse table. So that is relation, one-to-one relation is there. Now multi-dimensional. So from multiple tables it will go. Few columns will come from one dimension table, few columns will come from another dimension table, few key section will come, few measure section will come, few calculation will come. Like that, multiple tables will be used. It can be one to many or many to one, many to many, anything it can be. So in that case, we can tell it as a multi-dimensional. And if you are working in any project and that project is having suppose 5 requirements, 10 requirements, 20 requirements. So for few requirements, the approach is relational. For few requirements, the approach is multidimensional. So in that case, we can tell that we are working in a project which is having hybrid OLAP approach. Combined it is there. Some are multidimensional, some are relational, mix. So rollup plus mollup equal to hollup. That is called as hybrid OLAP. Okay, so that is only types of OLAP. Next is schema. Okay, this is another important topic. What is schema? What are the different types of schema? Schema is nothing but the logical description or logical representation. That is the generic meaning of schema. So if we are taking the example of database, what is schema? Then logical representation of a database is called database schema. Logical representation of data warehouse is called data warehouse schema. Logical representation of your big data project is called big data schema. Same thing. Suppose we are trying to understand what exactly this schema in normal meaning. What is that? You can take one example of your house. Suppose you have a plan to build a new house, maybe duplex or triplex or anything. You have one area, 2000 square feet or something. So within one day you cannot build the house. You have so many plans. When you can start, how many floors you can make it, which facing you will do, north facing or east facing, how many rooms you will make, in which style you will do it, and the carpenters will come from which places. They will stay here or they will prepare in their home and they will come and fit here, or what exactly? What is your budget? You will take loan or you have the means cash already present. So a lot of plans are there. Design. So for design also you will only prepare your plan, or then or you can take from some architect engineer the plan and you will do that. So all these logically you have to plan first. How you will maintain all those? Maybe in an Excel sheet or a Word document or in your pen and paper something. You have to make it ready everything, because in our memory everything cannot be written, or our memory is not like computer or anything. So we have to maintain somewhere in a file, in a Word document, in a PPT, in a Excel, or you don't have anything in a pen and paper also. So what is that? Based on that, whatever you planned, maintained, mentioned in your pen and paper, some diagram you did for your house, all those things, then you are implementing practically to build your house. So what is that then? That is your schema of your house. First of all, you pre-plan that, then you can go to implement. After implementing, maybe it will take 1 hour, 1 year or 2 year, 3 year, whatever it may be. That is different case. So pre-plan you have to do before the execution, before work, before implementation. That is nothing but the schema. So coming to this technology also, data warehouse we are working, database we are working, big data we are working, everything we are working. So before working, some structure is required. Suppose coming to database, how many tables will be there, what type of schema will be there, then which table will be related to which table, any correlation is there or not, foreign key primary key relationship is there or not, what type of data will be present, what will be the size of that data, then any restriction is there or not, then any access will be given for any specific customer, or all types of access will be given. These are the means prerequisites. So it of all of these information, how many columns will be there, what will be the data type, all those informations will be present in some schema or some table. So that table is called as a schema table, we can tell. So here HR schema we are using. In HR schema, all the representation of the tables which are exist under that it is mentioned. So high level we can get that in the HR schema. How many tables are there, what kind of table, what type of data it is present, how many columns are there in all those tables. So these are nothing but the logical representation. So first the structure will be created. Who will create all those? Architect people, technical architect, testers, developers will not involve in the technical architect people will design the schema level. Okay, so this schema is nothing but the logical description or logical representation of entire database. That is database schema. So coming to data warehouse also, the logical representation of entire data warehouse. is called as data warehouse schema. So that schema is divided into three parts or three categories, types of schema. One is star schema, second is snowflake schema. Okay, first one is star schema, second one is snowflake schema, and third one is galaxy schema or fact conciliation schema. So we'll start with this first one, star schema. Okay, so in this star schema, the logical representation where it will make with some diagram or anything, it looks like star. That's why they have given this schema as star schema, given the name as star schema. So how it will be present? Fact table and dimension table you already understand now. So both kind of table will be used in the project. So in middle the fact table will be there, and this fact table will be our final table to generate the report or work with the business. Higher management business persons will use this table. Now the data will come to this fact table from different dimension table. So this is one dimension table, maybe product. This is one dimension table, maybe student. This is patient. This is time. This is some other you can tell region or something, suppose, or address. So from different dimension table, based on the common column, key, measure, section, area wise, if we'll combine the data with this fact table and dimension table, few will come from this, few will come from this, few will come from this, like that. Consolidated data which are only required, those will be present or come to this fact table finally. Okay, so how it looks like? It is in middle, and surrounding to that so many dimension tables are there, and this fact table is gathering the information from multiple dimension table, maybe 2, maybe 5, maybe 20, maybe 30. So at the end, if it is gathering the different informations from multiple dimension table, how it looks like? It looks like a star. That's why this type of schema they have given the name as star schema. So here all these fact table and dimension tables are directly linked in the star schema, directly linked. Suppose this is a product dimension table. Product ID is a key column. So that product ID, foreign key will be present in this fact table also, product ID. So these two can be joined. Common column can be joined. Similarly, here time ID is there. So this time ID is also present as a common column in this fact table, that can be joined. So each and every dimension table is having one primary key, and same key will be present in fact table also as foreign. So those two columns are common column. Based on that common column only, we can combine the data. So all these tables are combining, and some common information it is taking, and consolidated common summary information it is storing in this fact table. So one to one we can join or we can combine, not indirectly, directly. So here PID is there, here PID is there, direct we can join. No via media is there. Here time ID, directly we are joining, no via media. So if directly all the tables are joining, not indirectly, and many informations it is gathering from multiple dimension table, then this type of schema is called as a star schema. Now the extension of this will be called as snowflake schema, which can be indirectly also joined. So we can go with some other example. Okay, so in this example, this is star schema example. Fact table, this is in middle. Time key or time ID is one column. Here time key or time ID is there, time dimension table. Item key or item ID, here item key. Branch key, here branch key. Location key, this is locations table, locations key. So these four are key sections in this fact table. Now what are measure sections? Dollars sold, units sold. So these two may be directly present in any of these dimension table, or indirectly it is coming by doing some calculation or some expression. So whole together this is a fact table. So from where the data is gathering this fact table, it is gathering the data or taking the information data information from all these tables only, and directly it can be linked. Time key, item key, location key. No indirect is there. So at the end, it looks like a star. So they have given this name as a star schema. Now coming to Snowflake schema. Some will be connected directly, some will not connect directly. Indirectly we can connect. So if any indirect method is also there, then we can tell it as a Snowflake schema. And what is the meaning of Snowflake? Snowflake means normalizing. What is normalization? Already we discussed in the session, first class of SQL topic database. It will the process of splitting the data into multiple parts. Suppose in one place it is present, then it can be splitted into multiple places so that it will be easy. Small tables will be created. To make it easier, only normalization is happening. So this normalization is available in Snowflake schema, not in star schema. Star schema is denormalized because one table only present. Now those table will be again splitted in this Snowflake schema, so that we can tell it as a normalized. So Snowflake schema is normalized and star schema is denormalized. That is one difference. Okay, now in this example you can see fact cells. This is fact table. In middle it is present. So here date ID is one key column, store ID, product ID. These three are key columns. So if we combining the data from dimension table, how we can combine date ID to date ID? Okay, where is the date dimension table? This one. Okay, in this dimension table, date ID is one column that will combine with this one. Store ID. Here store ID is there. Now product ID. This is product ID, product dimension table. Okay, so these three tables are combined now. Now after combining, in this fact table, the requirement is need some week related information, month related information, quarter related information, geographically location information also it required, and brand of the product. Product name is here available, but what is that brand, company name? It is not mentioned. Brand also required, this fact information. And product category also required. What type of product? Electronics product or food related product or some grocery related product or medicine product or what product? That type also it required in this fact table. That is our requirement. So directly we are not getting from this product, we are getting a product ID, EN code, product name, brand ID, product category ID. That's all. What type of product we are not getting? So that is present in this product category table, in this table. So how to do? So this table and this table can be combined. Dimension product and dimension product category can be combined. So how to combine? Here also two columns are common, ID, product ID, and here also product ID. If these two are combined, then after we are combining, if these two are combining means the common data came here. Now that we are combining with these two, BIM product and fact cells here. So indirectly this data also it will come, product category also it will come. Directly it is not coming, indirectly it is coming here. Similarly, some brand name, brand ID is here and here also brand ID is there. Both are common. These two tables will be combined, these and this table. After combining, the company name or brand name also we are getting. Now we can combine with this product. It is coming. So indirectly brand also we are getting in this fact table. So some are coming directly, some are coming indirectly. So this table only again taking the data from some other table for more information. Maybe it will extend some other table, that can extend some other table. So many extension will be there. So those extensions are called as normalization. It is normalizing. Your one exam will be there in BTech, that is denormalized. That is splitted into yearly exam, that is normalized. again splitted into semester exam, again normalize, again splitted into trimester exam, again normalize. So this type of normalization is happening. So at the end, all the knowledge is required from all trimester. You should know all the knowledge. So that is the fact only. Finally, that is required. So finally, many information it is required in this fact table. So some will come from semester 1, some will come from trimester 2, some will come from another trimester 3, like that it will come. So some are directly, some are indirectly, it will come. So if this type of structure is present, then we can tell it as a snowflake schema. Snowflake meaning is normalized, normalization. And previously which we learned, that is star schema. So one is snowflake, another is star. Star denormalized, snowflakes is normalized. Direct plus indirect both will be present here. Connection in snowflakes. In star schema, all will be direct connection, no indirect. Okay, and all those are directly connected. That's why it is taking in this way. So looks like star, but it is not looking like star. Snowflake. So why they have given the name as snowflake? It is normalized. Name of or meaning of the snowflake is normalization. Since it is normalizing, 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 extending, 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 so the name they have given as snowflake schema. So this is the structure. Using this structure, we can work practically. That's why this is called as a schema. If you don't know which tables are present, which tables from which table connection is there, directly, indirectly, by seeing that easily it can be understandable because this is a schema. After that, we can implement practically using our tables and databases. Okay, so this is snowflake schema. Next one is galaxy schema or fact constellation schema. Okay, so galaxy schema means what is that? Just small extension of snowflake schema. So if the snowflake schema is having more than one fact table, then that is called as a galaxy schema. So here also you can see direct, indirect, both kind of connection is there. Fact table, this is one fact table, this is another fact table. So some are directly connecting. So this information also there, city information, region information. So region and the city is combining some common information. Then city and shop is combining again some common information. Then it is combining with this fact table. Now this one you can see direct one, no extension. Okay, now okay, see here also one extension. This is another one, client group. So it can stop here also. It is not like that extension is compulsory. It can go up to one extension, it can go up to 5 extension, no problem. However, how much it is required, in that way it will be extended, splitted, normalized. So what you observe here, same only like snowflake schema, same structure only you are seeing. Only one difference is more than one fact table is present. So snowflake schema and galaxy schema almost same. In snowflake schema, only one fact table will be present, but in galaxy schema, more than one fact table will be present. So that is one interview question also. How many fact table are present in star schema? How many fact table are present in snowflake schema? How many fact table are present in galaxy schema? So one fact table in star, one fact table in snowflake, more than one fact table will be in galaxy, not two. It can be 2, it can be 10, it can be 20, more than one. So the structure of snowflake schema is called as galaxy fact constellation schema, wherever more than one fact table will be present. That's all. So in this way, 3 types of schema are available in data warehouse ETL. Okay, so any doubt, questions from this schema related? This is very, very important schema also.
No, it
Sir,
is
in
clear.
office, which schema is using, sir?
That depend upon the project, but if you will take the percentage, 90% projects are using snowflake schema. Star schema is there in the project, and it will be very easy, straightforward, easy to write the query also. Snowflake schema, then little bit complex you will see. And again, fact constellation schema they are using is very, very complex. You have to do hard work. Lot of joints will be there, many functions will be used. So complexity you will get. So all are possible, all kind of schema they are using, but percentage wise, more and more is Snowflake schema only. Small project if you are working, then star schema. Big project, Snowflake. Okay, any questions from anybody? Rahul, Deepa,
No, sir, no questions.
Nidhi, Sipsai, Sairam, Vishnu, Jamir, Akshay, Chandradeep, all are fine?
Yeah.
No, sir.
Okay. Okay, now we put it. Okay, so can we continue or we can stop or we can take 5 minutes break and we will resume? You can tell according to that we'll do. Your choice.
Continue, sir.
Okay. So all are fine, we can continue or small break you need.
Fine,
Okay.
continue.
Okay, we can continue then. Next is metadata. This is also one interview question. What is metadata? Can you explain? Metadata, nothing but more information about data. Or we can tell in other sentence, data about data. This is the definition. Data about data or more information about data. Any sentence you can tell. That is the definition. So the data which are used to represent other data is known as metadata. So using one data, we are representing some other data. So that is nothing but the detailed information. So more information, detailed information, we are representing the data about another data. Any kind of definition you can tell. Okay, so metadata, one index example you can take. You have one book. Content is there in first page, second page, third page, which chapter is having what type of topics, then in which page it is available, how many pages it is there. By seeing the index, we can able to understand all those. So those index is nothing but the metadata, index of the book. So similarly, if we are working in any project also, detailed informations will be present in some other table or some document related to our project. So those are nothing but the metadata. Okay. So this metadata we can say in other way also roadmap to the data warehouse. Our data warehouse roadmap this is. Metadata in data warehouse define the warehouse object. So it will define the objects, different objects of our warehouse. So this metadata is divided into three categories. One is business metadata, second is operational metadata, third is technical metadata. So what are those? Any technical information is present in some table, then that is called as a technical metadata. If in any document it is present, then that is called as a technical metadata document. So what type of technical informations will be present? Database name, schema name, table name, column name, sequence of those columns, then size of the table, then what type of data type will be there, what type of values will be present. These informations will be present in one of your document. You will receive one document. In that they will mention that. So that document is called as technical metadata document. All the technical informations will be present. Now another document is business metadata document. Your business informations will be mentioned in that document. What exactly this business, what is your main objective of this project or requirement? Okay, what type of information should be extracted? This same kind of thing is available in some other company also. So what is your specialty? Any policy, any rules, regulation is there or not? Any restriction is there or not? So purely business related. So business information is present, how you will book the profit. More about the business only. So business related information is present in the document, and that is called as a business metadata document. If in a table it is mentioned, then that is called a business metadata table. If in a file it is mentioned, that is called as a business metadata file. So it can present anywhere. So basically in real-time project, what document only they are giving, and all these will be mentioned. Okay, so we can tell that as a metadata document. Information we are telling, then metadata information. Another kind is operational metadata. So this operational metadata includes how to operate. Suppose one banking project you are working. So that project is very old one. Now one new feature is added in that bank. Suppose IMPS you are doing, Citibank project you are working. IMPS you can do one-to-one at a time. That is already exists, this functionality. Now in this current requirement you got that IMPS can be done at a time, maximum 100 people. Just you can set the name, date, time, amount, all those things with different persons, 100 persons, so that at a time it will trigger. All persons will get that amount within a fraction of second. IMPS, money transfer. That is the new requirement you got. So how to do that? From where to add, how to process, what to click, what not to click, what to select, what not to select. These are some process. So these processes are called as operation, means how to operate. You should know. Then only you can able to work. So the step-by-step process, or how to operate that, and what are the process to execute that, those are called as operation. So those operational activities or steps or process or informations are mentioned in some document, then that is called as a operational metadata document. That can be a file or word or table, anything it can be. So that is operational metadata. Nowadays, in all projects, they are giving only one document. Whenever you will start working, you will get one document that is that will be called as design document, or some are telling it as a statement of requirement document. Some are telling some different names are there. So any name you can tell. Requirement document also you can tell. In one document, everything they are keeping nowadays, because small document, 1 page, 2 page, 5 page, again unnecessary, it is giving confusion. And why unnecessary, you will use more and more documents. In one document only they are keeping everything. This section they mentioned, this is business information, aim of the project. This is architecture, operational. So how to operate, all those things will be mentioned in one architecture diagram. That is operational metadata information. Now technical related information, in some other pages they will mention, that is technical information. So document is only one, and everything they will mention in that document only, page wise, section wise, heading wise. But earlier, if we will go before 15-20 years back, at that time we are getting multiple document, business metadata one document, operational metadata one document, technical metadata one document. Now they merged everything and telling one different name, that is design document or requirement document or statement of requirement or any other. Okay, but process wise or technical term wise, you should know what is technical metadata, what is operational metadata, what is business metadata. So in this way, this is 3 types. Okay. Now next, types of dimension. So dimension, we already understand what is dimension table, what is fact table, all those things. Now coming to this dimension also various categories it is available. One is junk dimension, another is infrared dimension, confirm dimension, degenerate dimension, role playing dimension, sunken dimension, static or unchanged, rapidly changing, slowly changing. Okay, so out of all these dimension 9 types, at least 2 to 3 types will get compulsory in the interview, and 100% sure set is last one, slowly changing dimension. Okay, so that is little bit lengthy. Tomorrow we will discuss. Today we will complete all these 8 types. These are very simple and straightforward, just 2 line, 3 line definition only. Just try to understand that, sir. So out of all these 9, the uses in the real time will be last one only, and others are very rare cases we have to use. But if somewhere it is mentioned the names Truncan dimension or role playing, you are not able to understand your requirement document, then it will be problem, and you are asking to your team member what is confirmed, I am not understanding. That is not a good thing. So you should know all these names, but the more uses will be last one, slowly changing dimension. 95% projects are using that one. Okay, first one is junk dimension. Junk dimension is a single table with a combination of different unrelated attributes. So many unwanted informations will be there. So many foreign keys, primary keys will be available here. So if we'll try to understand this junk dimension, so many junk values we can see. Unnecessary values are present. So many extra columns are there. If 10 columns are required, then 200 columns are present in that table, which are not at all required. Junk values we can see. So, and another thing, so many nulls are there. So we need just 5 columns and 20 records around. But in that 1 lakh rows are there, 200 columns are there, and many values are null, 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 null. Junk values are there, null values are there. So unnecessary that is coming. And whenever we use those type of table, it will take more time also. Unwanted things are present. More data, more time it will take. So those type of dimension table are called as a junk dimension. Okay, so here you can see this is one table, gender table, ID and gender is there, male, female. Another is marital status. Then again we are taking 1, 2, 3. ID is there, and in status married, single, and another is divorced. 3 types of status is there. Now if we combining these 2 tables, then how many combinations it will come? All row will be combined with all row. So first row will combine with all these 3 rows. The second row also combined with all these 3 rows. So at the end, how many total combinations? 6 combinations we are getting. So if we see these 6 combinations, then many are invalid, we can see. So to make it as a sorting order, I have given here 1, 2, 3, 4, 5, 6. But it will be same, 1 and here 1, then 2 and 2. Similarly, all these are combining. So if we'll see here, total how many persons are there? 3 persons are there, but 6 rows we are coming. So some conflict is coming here. 3 persons are there, then how 6 rows will come? 6 rows means 6 customer information. 3 customer information, how it will come in 6 rows with 6 customer information? Some conflict is here. So now if we'll see after combining, one male is there, maybe male ID is 1. To distinguish, I have mentioned this as 1, 2, 3, 4. So the same male person, it is mentioned as a single. Same male person, it will be married, and same male person, it will be divorced, because this line is combining with this, this, and this. So this first male is married, this first male is single, this first male is divorced. How it is possible? One male person we are taking, either he is married or he is single or he is divorced. Anyone is possible, but 3 are not possible. But here we are getting 3 combinations. So this is a wrong approach. So how we will take the data, which is correct, which is incorrect? Lot of confusions are coming. So this is a junk value, wrong value, unnecessary, unwanted values. So this type of table, if you are getting, then that is called as a junk dimension table. So many unwanted things are there which is not at all required and giving lot of confusion. And to correct this also, lot of time taking you will get. So this type of dimension table are called as junk dimension table. Okay, so next dimension table, infrared dimension table. The dimension which is important to create a fact table, but it is not yet ready. Okay, so to create a fact table, suppose 5-dimension table is required. From 5-dimension table, one fact table we are doing in our project. Out of 5-dimension table, 3-dimension table are ready. Developer people already developed that, data is there, data loaded, everything is ready. Rest 2-dimension table is not yet ready, but that is also required. Those two also required. Maybe it will take for the developers to complete another 2 days or 5 days, whatever it may be. But that is not yet ready. So that dimension table, we can tell it as a infinite dimension table, means incomplete dimension table. That is also a dimension table, but not completed, incomplete one. It will take some time to complete, but that is dimension table only. So incomplete dimension table, we can tell it as a infinite dimension. Okay, so in that case, if requirement is urgent, then what to do? So for that, one dummy table or temporary table will be created by taking the data which are exist and in progress from that construction or design of that infinite dimension table, and that will be used for the fact table because that is not ready. You don't have bike means you will not go to your friend's village. It is not like that. Temporarily, you can arrange some other bike from your friends, or you can go by taxi or something, or train or flight. So if that is not completed, some other table also we can use, or one temporary table can be created for temporary. That is called as a one dummy table, temporary table. It will be not stop your work. So our table is not ready, I can sit, I will not work. You cannot tell like that. You have to go with some other approach, alternative approach. Next is confirmed dimension. Confirmed dimension is the dimension that is shared across multiple data mart or subject area. So some dimension tables are there, those are already confirmed. And whenever you are getting, suppose this March release, you got 2 requirements. In April release, you will get 5 requirements. In January release also, you got 3 requirements. Every month you are getting 2, 3, 4, 5 requirements in your project. You have to work on those. So wherever you are getting the requirements, for 3 or 4 dimension tables are there, those are 100% confirmed to use. Compulsory you have to use. On top of that, some other additional dimension tables are there. They will give in the requirement. This is extra table. That is extra table. But some common dimension tables are there. Any requirement you are getting, Ram, Dam, Syam, Soni, Rakesh, Rahul, everybody in your team are using those tables, common tables. Maybe 3 or 5 are there, which are already confirmed. Blindly, you can have to use that. Without that, you cannot start proceeding your work. So those type of confirmed dimension tables are called as confirmed dimension, which are already confirmed. And for multiple requirements, you will use that. Which are not ready, that is infrared. Which are already ready and confirmed, then that is called as a confirmed dimension. Okay, so here two confirmed dimension tables are there. One is customer information, customer dimension table, and another is product. These two are compulsory, you have to use in your project. Any requirement you will get. Apart from that, some other tables are there. So those will be used, not used based on the requirement. But these two are compulsory. So in that case, we can tell these two tables as a confirmed dimension. Next one is degenerate dimension. What is degenerate? Degenerate dimension is when the dimension activity is stored as part of fact table and not in a separate dimension table. Okay. So using the fact table, this table will be derived. Some dimension table will be derived. Suppose A is one dimension table, B is one dimension table, C is one, D is. Using some column, major column and key column, combined data we are taking from all these four, and we are generating one dimension table that is called as, suppose any name you can give Z. This is one fact table. So now this is separate. Z is one table which is a fact table. Now without considering this A, B, C, D, some information, leave about that now. We can consider Z only. This is gone now. Already combined, the data came here. Now everything done. Now some other informations we require. using this Z table only. So that information we can get in A or may not be A, in B may not be B, C may not be C, D or may not be C. It can directly present, indirectly present. So don't bother about that. Our main concentration is Z table now. So using this Z table, as per our requirement, we can create a sub table. Few informations we need in that requirement. So using this data in this fact table Z, we can create another table. Few columns we can take and a few grouping we can do, or any union or any set operator we can use, whatever it may be. So using this fact table, we are creating some more table or new table, which will be the dimension table, not fact table. So using this fact table, if you are creating a new dimension table, then that is called as a degenerate dimension table. Suppose another table created, that is T. This is a dimension table. What type of table? Dimension table. So from which information this dimension table is created? From one fact table it is created by taking few information. So this T table will be called as a degenerate dimension table. Okay. Role playing dimension. Okay, so role playing, this is also compulsory required, and this is the means role play. Suppose one case we can take, your project is related to holiday related. Okay, so you are selling some product, some store is there, retail shop, retail project you are having, some retail shop is there, any warehouse, for example, you can take Data Mart, Gmart, or IKEA, or so many are available in USA, UK. Any one you can take the example. So many holidays are there, national holiday and weekend, Saturday, Sunday holiday. So holiday is compulsory, those shops are closed. It will not open. Maybe in India it is opening, but in out of country, many country, Saturday, Sunday is closed, national holiday is closed. They will not open. So whenever the selling is going on, day by day, date by date need to be mentioned in the tables. So one table will be required, holiday information. Otherwise, how we can maintain? Which day is Saturday, which day is Sunday, we don't know. Which day is national holiday, we don't know. So compulsory that is required to know the information, because based on that hourly basis the billing is happening for the employees, suppose, so who are working in that shop or in that retail industry, who are working, for them 8 hours per day required, 20 working hours, 20 working days per month, and maybe 3 national holidays there. So that also it will deduct. So 20 minus 3, 17 they work. So hourly basis it will be billed and they will get their salary. That is the requirements of. So in that case, what will happen? One table is required for getting the holiday list. Otherwise, we don't know. We are in India, that is from some other country, Australia or Singapore or Canada or somewhere. We don't know what are the national holiday and weekend date time, also some difference is there, so it will mismatch if we consider our holiday. So what to do that? One compulsory holiday table is required for that. Based on that we can work on that requirement. So any new requirement, new features is coming, we have to use that. That is the role playing, role model. That table is not present or holiday list we don't have, we will not proceed anything. We'll stop there only. Any requirement you will work, holidays must require. Otherwise, all their salary will be wrong calculation only. So this is one example. Similarly, for each project, 1, 2 table will be there, which will be behave as a role-playing model. Compulsory it is required. Without that, you cannot proceed in a single step. So those type of tables are called as role-playing models. Okay, so in this terminology wise, we can tell that type of table as role-playing dimension table, or informations then role-playing dimension. Okay, so this is some table, it is taken dimension, date and cells. So this is required for each of the requirement in that project. We can tell it as a role-playing dimension. Next is shrunken dimension. What is shrunken? These are just concept only. Try to remember if somebody is asking. Otherwise, uses will be very less. Last one, slowly changing dimension only, very important. Okay, so next is sunken dimension. What is sunken dimension? This is a subset of another dimension. One dimension table is already there, A. Okay, so A is one dimension table already there. By using the data of A table, another dimension table is creating, B suppose. So B is deriving from A dimension table only. Then B table will be called as a shrunken dimension. If any dimension table is deriving from another table and that will behave as a subset of this table only, then that dimension table will be called as shrunken dimension table. Simple only, nothing easier. So here also primary key will be there, then some measures section, some detail information will be present, but this is a subset. Not 100% informations are present which are present in A. Maybe 5%, 10% or 20% informations are there. So we got one requirement in that all these A table informations not required, just 20% or 5% informations are required. So why unnecessary this big table will be used? Just make or create a short table, developer people will create one small table which are required exactly for that requirement. So they are deriving or generating or creating that new table by referring to this existing dimension table only. And as per the terminology, whatever they have defined these concepts, they mention that if any dimension table is generating from another dimension table, then that is called as a shrunken dimension. If any dimension table is generating from fact table, existing fact table, then that is called as, before some time we discussed, that is another name. So shrunken means dimension to dimension, and degenerate means fact to dimension. Fact table to dimension table, it will generate. Dimension to another dimension table is generating. Then it is called as shrunken dimension. Reverse. So shrunken and degenerate. What are the difference? They are asking. So you can tell them. Next is static or unchanging dimension. Okay, so few informations are present in some tables. Those are static, no change. Every time that will be fixed data. New data will not come. So those type of tables are called as static or unchanging dimension table. Okay, so suppose one company information is there. So what is the company name? In which country their branches are available? What type of departments are available, like finance department, IT department, HR department, then accounting department. So these are some departments in that company, and those companies are present in suppose 3 countries: US, UK, and India. And these 5 departments are available for that company, and they are having some product. So that product only they are selling. They are not taking any new project from any client. They are doing their own product and they are selling their product. So here all these are fixed. Their product is not changing. Their company name is not changing. Then their departments which are available also not changing. And what we can say, the branches which is available in 3 countries also not changing. All are fixed. So those informations are mentioned in one dimension table. That dimension table we can tell it as a static or unchanging dimension table. If their salary is mentioned, then salary can be changed. Address is mentioned, address can be changed. Phone number is mentioned, phone number can be changed. So changeable things are not mentioned. Unchangeable items are present in that table. So those will be fixed only. Static. Static means fixed or unchanged. So unchangeable items or values, fixed items values are present in a dimension table, then that is called as a static dimension table or unchanging dimension table. Next is rapidly changing dimension. Okay, so few dimension tables are there. The data will change rapidly, frequently, quickly. It will change. Maybe every day it will change, or maybe every week it will change, but rapidly it will change. That is called as a rapidly changing dimension. So any example we can take. Suppose one table is there. In that table, it is maintaining with the daily expenses or daily sales items, price, and all those things. So for one retail shop only, that is maintained in the table. Daily laptop, suppose daily 5 laptops they are selling. It is not like that. Maybe 0, maybe 1, maybe 10, maybe 20. That is for laptop product. Another product they are selling in that retail shop. Maybe some wood furniture item. So any item we can take example that also can be 0, 1, 2, 3, 4, 5, 6. So daily basis it is keeping changing, but in the table they are maintaining that. So that table we can tell it as a rapidly changing dimension table, RCD. Daily basis it is changing. Price vegetable they are maintaining, suppose in one table. So any vegetable item you can take or any fruits item. So today it is having one price, suppose tomato 1 kg 20 rupees. Tomorrow it will be 25. Day after tomorrow it can be 15. After 3-4 days it can be 60. So day by day or frequent basis it is changing. So those type of informations are present in any table, and that is called as a rapidly changing dimension. So any kind of example you can give, rapidly changing. And last one is slowly changing dimension. So few dimension tables will be there. The information which are present in those tables, it will change very slowly. Once it is changing means 1 year, 2 year, 5 year, 10 year, it will take time. Then it will change. So what will be the example? Normal example, behavior of a kid. So one kid example, we are taking one baby. We will not expect that within 3 months he or she can talk and he can go to school, he will do a job. That is not at all possible. So the behavior we have to wait. If we want the expectation to talk with that baby, then we need to wait for 2 years or 3 years. Then only he can talk with us. If schooling we are expecting, then we have to again wait for 3 years, 3 more years. Then high school, then college. So for job, we have to wait for another 15 years or 20 years. Then we can expect that that baby will complete some college engineering and say something, and he will get a job. So these are taking very slowly, this behavior. Now you are joining one company. So today you join one company, TCS. It is not like that tomorrow you will quit and day after tomorrow you will join IBM. Another day you can join in Accenture. Another day you can join in Wipro. It is not possible. If you are joined in any company, maybe you will work for 1 year or 2 years. After that, maybe you are not able to perform, or you are required for some more salary, or your requirement is to learn so many new technology. In that case, you can plan, okay, I will quit this company, I will go for next company. Within 1 month, you are not quitting. Within 6 months, you are not quitting. It is taking some time. 6 months, 1 year, 2 year, 5 years, it is taking. So that example, slowly changing dimension. Another example, you can take credit card you are using. So you have one credit card, Citibank. So frequently you cannot change that credit card. You can use for 1 year or 2 years something. After that, if you are not getting the offers, so many new features are available, offers are available in some other credit card, Standard Chartered Bank or ICICI Bank or somewhere. Then you can plan to switch that card. You can quit this, you can join another new one. So that will take some time. Immediately you will not change, because now you have taken one Citibank credit card, then maybe you got some offer features which is suitable for you. Then only you have taken. It is not like that blindly you have taken. They explain so many features and all those things. You inquired some other cards also. Then you finalize that, okay, I will take Citibank credit card. So why you will go for immediate change? So if slowly you are seeing 6 months, 8 months, 1 year, and now new features are coming, lot of things changed, happened. So other credit cards are giving these features offers, but I am not getting, and so many charges are there. Anything I am doing transaction, 1% tax they are taking, transaction charges, but other credit card already removed that. So why will not go for that? It was working good earlier, but now it is not working. Okay, you can go for change. So some informations are there which will change very slowly. Those type of informations are called as slowly changing dimension. And if it is mentioned in a table, those tables are called as slowly changing dimension table or SCD table. Okay. So these slowly changing dimensions are having multiple categories types. This will take some time. Next tomorrow will be that.